Okay. So hyperbolas. So I realized that if I wanted to copy this correctly, I just have to screenshot it instead of copying the text. Oh, I have to adjust. Anybody uses OneNote regularly, and do they know how to do have your preferences set so that your page is always a letter size? No? Okay. All right. So the equation for a hyperbola looks just like the ellipse, except for one minor thing, and that one of the things that's being squared has a minus sign. So in this particular example, or in this particular theorem, x squared, if you were to FOIL everything out and just look at the x squared term, that's a positive term. And then if you look at the y squared term, it's a negative term. So when you see an equation and you see an x squared and a y squared present, you know it's not a parabola. So it's either going to be an ellipse or a hyperbola. And then you look at the sign in front of the x squared and the y squared term. If they have the same sign, either both positive or even if they're both negative, then you know it's going to be an ellipse. And if one of them is positive and then the other one is negative, then it has to be a hyperbola. Okay? So that's the quick, easy way of checking between and distinguishing between the conic sections. So this equation with a minus sign in between describes a hyperbola. And so hyperbola also has focus points, foci, and the foci is going to be along the major axis, going to be, in this case, along the x-axis. And so x minus c and x plus c would be the foci. C is a little bit different from last time. When we had an ellipse equation, the c was a squared minus b squared, or c squared was a squared minus b squared, or b squared minus a squared if it's, depending on which way the ellipse is oriented. But the hyperbola is different because it's a squared plus b squared. So that's the difference between the hyperbola and the ellipse. Now we have a center point for the hyperbola, but we generally, I guess you can still think of it as a center point, but the hyperbola is like a couple of, I want to say parabola, but it's not really a parabola, but a couple of parabola shapes pointing in opposite directions. So the middle is going to be their center point. And based on this equation, the center point is x naught, y naught, and then there are vertices for those things, and they are at the plus a minus a business from the center. Now, they also have asymptotes. And asymptotes come from the equation of the line. And so they're going to have, I guess you would call them slant asymptotes if you're just looking at a regular polynomial or something, or a rational function. So they would have asymptotes. We can do this all kind of in general, and then we'll come up with an example. So let me see if I can try to sketch all these components of the of the hyperbola. So let's start off with a center point. I guess this is not HK anymore. It's X naught, Y naught. That'll be like your center point. And then this is opening sideways. And so with a distance of A units to the left and to the right from the center point, will be your vertex. And I guess I'm moving towards trying to draw this now, because when you're drawing it, you want to account for those asymptotes. And those asymptotes, you don't want to just, try to graph the asymptote. You want to do it in the frame of reference of where the center point is. And so what you could do from there is figure out that your B would be some distance. It's under the Y, so it's going to be a Y distance up and down. Although that doesn't look like it plays much of a part in this. It actually will when you create what's called the eight. Create. It's like a dad joke. Create a box around the center point, going the distance of A in both sides and the X and B in both sides and the Y. And then from there, if you draw a line passing through the center and going in a diagonal, your slope, if you look at your slope, it's rise over run. It's B over A, right? And so if you look at the equation of the slopes or the asymptotes, the slopes of the asymptotes are B minus A, plus and minus. And so we can account for the plus and minus business. And you can see that easily from the box that you would draw. So those are your asymptotes. And then the vertex, like I said, is going to be X naught plus A, X naught minus A with a Y value of Y naught, whatever that center point was. So we can draw those vertices, and then we know that it's going to open sideways. So we can just draw a shape that's eventually going to go to the asymptote. On both sides. So there's your hyperbola. Okay. Some computation will lead us to the C. C would be from X naught from the center point, and then you go C units to the left and to the right. And the C units, remember, it's A squared plus B squared with a square root. So it's going to end up somewhere on the other side of the, on the focal points of the hyperbola. So you have focus points on those sides. And that would be a distance from here, a distance of C, which is the square root of A squared plus B squared. Okay. So any questions about trying to draw a hyperbola? So one of the key things, of course, is if you have X squared and Y squared, one of them is positive, the other one's negative, and then you have a stray X or Y term somewhere, then you know you're going to have to complete the square, just like we've done before. And then when you do that, then when you're completing the square, you're actually shifting your hyperbola to some other place away from the origin. All right, let's do an example. By the way, this was an example where the y was negative. If the x squared was negative, then it would be a hyperbola opening up and down. All right, we'll start with, I don't know, what should we start with? 19, 20, 21. Let's do 23 where we actually have to complete the square because we're all experts at that already, right? All right, x squared minus y squared plus 2y is equal to 2. So I see the x squared and the y squared, not a parabola, so it's an ellipse or hyperbola. And I see one of them is positive, the other one's negative. It has to be a hyperbola. Okay? The y is negative. The x is positive. I mean, you really should complete this by making sure that the right-hand side is equal to 1, positive 1. But if we just divide by 2, we'll see that the signs won't change for the x squared and the y squared. So the y is negative, which means this is going to open sideways. All right? So that's the thought process. Not writing it down. You guys remember it. Okay, so let's complete the square and then write it in the form that they suggest we write it in. And so we have, I think it's just plus 1, right? X squared minus, now I want to factor out the negative sign. Oh, I don't know how you guys might do your completing the square a little bit differently, but I hope it still makes sense. You know, sometimes you add and subtract on the same side, but here we have an equation, so we can add on one side and add the same thing on the other side, blah, blah, blah. Anyways, looks like 2 divided by 1 squared is 1. And then I'm adding a 1, but I'm actually adding a negative 1 because of the negative sign in front, the negative sign that we factored out. So that would be a minus 1. Makes x squared minus y minus 1 quantity squared is equal to 1. I did that right, I hope. Okay. All right. So now that we know that, we know a is equal to 1, y is equal to 1. Or b. A is equal to 1, b is equal to 1. We're going to use this information later on, but c is equal to the square root of 1 squared plus 1 squared. We have x naught is 0 and y naught is 1. So our center is going to be 0, 1. So it looks like this has been up 1 unit. Since a and b are equal to 1, the slope of our thing is going to be 1, but we're not going to be too concerned about the slope because we can get that information from the drawing after if we can draw the box. So let's draw the box. Let's draw our axis first. Whoops. I thought I picked black. Draw our axis. And then our center point is going to be 0, 1. Which is really not even going to be part of the graph, right? But at least it's there. And we're going to go 1 unit to the left and 1 unit to the right. That's A. B happens to be also 1 unit, so that's 1 unit up and 1 unit down. So A being 1 means you go up and down, or left and right by 1, and then B being 1, you go up and down by 1, and then you create your little box. I think I accidentally press my keyboard every once in a while here. And so this is going to give me my asymptotes. Okay. I know it's opening sideways because the y is negative, the x is positive. And so I know my vertex is going to be x naught plus 1, and then the y value is the center point 1, and then x naught minus 1 with the y value of 1 from the center point. Then that's it. Okay? Yeah. Asymptotes where the diagonal from the box that I drew. So within the box, you would draw the diagonal that's passing through the middle, passing through the center point, and then those will serve as your asymptotes. And you just have to remember that it's not, it's not opening up and down, because once you draw the box in the asymptotes, it's a question of whether it's opening up or down, and you have to know that from the beginning. The box, I started with a center point, 0, 1, and then I added along the x, I add 1, I add a, and I subtract a, and then I add and subtract b. And in this problem, they're both equal to 1, so it looks kind of deceiving, but that's what we're doing. Yeah, it's if you just follow the steps, I think it's fairly straightforward. And kind of like the ellipse is almost the same thing. You have A going along the x and B going along the y, and then instead of making that box an asymptotes, you would just, your ellipse would just be in here. So I think the construction of an ellipse and a hyperbola is almost the same. It's just a matter of what you want to assign from there. Like if there was a plus in between here, then we would be drawing the ellipse inside instead of the hyperbolas going out. Yeah. Whatever is under the x, and then the vertical is whatever is under the y. Yeah. Oh, from the beginning, it's x minus 0 and y minus 1. Except when it's just x squared, you have to understand there's like a minus 0 there. Okay. Anything else? Those are good clarifying questions. This is a pretty algorithmic process. And so if you just follow the algorithm, you'll be all good. Any questions? Okay. Let's see. And we can do another one, but you're all good with this, right? Let's see what kind of other questions they come up with. Oh, here, they turn it around. So they want you to find an equation of the conic section given these pieces of information. So let's try to remember our parabola and the formulas involved with the parabola. And then our ellipse and hyperbola is pretty much the same, right? So let's see if we can do some of these problems. Let's try to do number 33. Didn't copy it yet. 33. Let's find a parabola with the focus of, oh, sorry. Let me go back. Speaking of focus, let me just go back to this example and talk about the foci, remember, is square root of 2. Well, it's not square root of 2. C is equal to square root of 2. So what you would do to get the focus points, just as a last step here, is you go, this is 1. Square root of 2 is bigger than 1, right? So another measurement a little bit bigger than 1 over here. This is a distance of square root of 2. And then that's your focus. And then you have the same thing happening on the other side. Okay. Forgot about the focus. All right. So back to our finding equations. We want to find a parabola with a focus that looks like the -4, comma 0 and a directrix of x is equal to 2. So directrix is x is equal to 2. Let me just try to sketch that out to get some idea of how I might want to approach this. So I kind of see the directrix as a vertical or horizontal line. Vertical. X, right? When x is equal to something, and it's like putting something on the x-axis, and it doesn't matter what y is, x is always going to be equal to 2. So this is your directrix. Your focus is 1, 2, 3, 4. Your focus is -4. And so you should have a parabola. Remember, the parabola is equidistant lengths from the focus and the directrix. So can you find the vertex? Tell me where the vertex might be. I mean, we can find the vertex after we nail everything out, but just by looking at this picture, what is it? -1, comma 2? -1, comma 0. So -1, comma 0. This is -1. Oh, this is -1. Right? So it looks like it should be along the x-axis, the shortest distance between the point, the focus, and the directrix. The midpoint is going to be -1, comma 0. Okay. So that looks like it's going to be the vertex. So we should expect that after we do all our work. Is this a parabola opening up and down? Or side to side? It's opening side to side. So which of the variables x or y is going to be squared? Y is going to be squared. Okay. So you can see that there's a lot of information you can get by just drawing a sketch. Okay, so we know this is going to be opening sideways, not just sideways, but opening to the left or right? Left or right? Left. Opens left. And that should also give you an idea of what the sign is for A, what the sign is for the, which one was the squared again? Y or X? Y is going to be squared. Opens left. So that's going to, well, let's start building our equation. So we know that our equation is going to be x is equal to, did we put a plus h on the left or right? Forgot what we do. Yeah, it's on the right side. So basically this equation down here. So x is equal to a and then y minus h plus k, where h and k is going to be the vertex. Is it the vertex? Yeah, it's the vertex. Is it? Yeah. And then a will tell you how wide it's opening up. At least we know that since it's opening to the left that a is going to be negative, right? So we can already say that your point here is minus 1 comma 0. So we actually have h and k identified already. And then how are we going to find a again? We can find it using the focus or the directrix, right? What was the equation for the focus? It's what? Or the directrix. Which one is easier? I think the directrix is easier because it's just one thing. Or you can get the x value of the focus. What is it? Oh, directrix. C? What's C? Oh, we put C. Oh, B and C. Oh, crap. All right, let's use B and C. Sorry. Oh, this is squared also. Thank you. What was the formula again? C minus 1 over 4a. And this is this the focus or directrix? The what? So this is the directrix. So x is equal to this thing, right? Our directrix is x is equal to 2, and c, we already said, was equal to 0. So we have 0 minus what? Minus 4, 1 over 4a is equal to 2. And then solve for it, I don't know, reciprocal or something. Say it again. A is equal to 8. So that looks like our A. So we got A, we got B, and we got C. So we're done. X is equal to negative 1 over 8. Y minus B, what was B? Is 1 plus 0. So this is our equation. Okay? Pretty straightforward. All right, let's do one more. Oh, I need to look at it. So should we do an ellipse or hyperbola? Hyperbola. Looks like we got 43 to 40 something. What? 45? All right. So hyperbola, we have vertices for the hyperbola, and if you look at the vertices, we got -3, and for the x, -3 for the x again. So it looks like the x is going to have the same vertices and different y values. So can you imagine if this is opening up and down or sideways? We'll draw it and then we'll see it. It'll be opening up and down. Okay, so the foci will be along the major axis as well, -3. So x is -3 is going to be our axis. We have to somehow find the center of this hyperbola, and by either looking at the vertices or by looking at the foci, if you find the middle of those two pairs of numbers, you'll get the middle of the graph. Okay, I think the tricky part is finding b in this case. So we know that this is going to be a hyperbola, and let's start drawing as much information as given to us so that we can fill in the rest of the blanks. So 1, 2, 3, -3. I have -4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So those are the vertices. I think I was drawing the and then it opens up and down. We also have the focus points. -3, 7, so I'm just one more unit up. Oh, that's -7. 6, 7, 8, 9. So that's 3 units up. And -7, so -4, -5, -6, -7. So 3 units up and 3 units down. So we have some idea of how this thing's going to look like if we draw our box as much as we can draw, because we don't have the big picture yet. We can at least draw the box going this way. And then we don't know how far it's going to go to the left or to the right. That's the focus is controlling that at this point. So my question is, what's the middle? Where's our center point? It's -3, right? What's the y value? +1? Just the middle of between -4 and 6, or between -7 and 9. The middle is going to be +1. So we have our center point. So we can begin. We also know the distance from the center point to at least the top part. And that's going to be, it's going to be a b value. It's going to be the one under the y. It's the vertical distance. What is it? 5, right? From the vertex to the center. Which one's negative? X is negative. Opening up and down, x is negative. All right, so let's start writing our equation. You guys want to, is it okay to put the negative in front of the x first, or do you guys want to see the negative in the middle? Okay, well, let's put the y first. Y minus what? Y minus, what's the center point again? What's the y value of the center? Y minus 1, quantity squared. And what's the b value again? 5. Don't forget to square it. 5 squared minus x minus what? So x minus negative 3, so that's like x plus 3. And then this is what we don't know at this point. The b is equal to 1. So based on the information, and then after visualizing this, after drawing it out a little bit, you can see that this is a general setup for your hyperbola. I just need to figure out what b is equal to. I think there was a relationship between a, b, and c, and I think I know what a is. Oh, a is equal to, well, I guess this should be a, sorry. So a is the horizontal distance, and at this point is unknown. So, like I said, I think there was some relationship between A, B, and C, right? So the foci has some information about C. And do you remember what the formula for the foci was? What was it again? Oh, the foci in the example that we had was opening sideways. This is an opening up and down. So let's just adjust our foci. So our x will remain the same, right? What's our x value? Negative 3. So the foci will have an x value of negative 3. And then it'll be the center point plus or minus some c value, right? So if we take a look at the hyperbola again, the foci is going to be plus c, negative c, but here it's along the x because this is sideways. Since we're going along the y, it'll be the y is the one that's plus c minus c. And c is equal to the square root of a squared plus b squared. So from there, we should be able to find our unknown. In this case, our unknown is a. So c is equal to what? It's one of these. What's c equal to? I guess we have to choose one of them. 1 plus c, that should probably equal to 9 or something, or 1 minus c should equal a negative 7. Right? So what's c equal to? 8? So c is equal to 8, and b is equal to 5. So we should just be able to solve for a. In fact, we probably just solve for a squared and then plop it into the equation. So a squared is equal to 64. So a itself would be the square root of 39, but the formula is looking for a squared, so we might as well use that. And then that's it. So we have y minus 1 squared or 5 squared, or maybe we could put 25 here, minus x plus 3 squared over 39 is equal to 1. Yeah. Oh, okay. Yeah, so the x naught plus c, I didn't copy and paste the other way. This is opening sideways. So when you're opening sideways, this is your formula. Let me actually add on to our notes here. And I think I have it. I don't know why I didn't just copy and paste it. For the hyperbola opening up and down, oh, see, I don't like this. They changed the A and the B. I think I have to rewrite my notes. So let me do some fixing here, and then we'll take a look at your question again. So when your parabola is opening up and down, then your foci is going to be on the y value. And the y value will keep your center point y value, which in this case is 1. And then you do the plus or minus c to that 1. Okay? So b is going to be square root of 39. If we look at it opening sideways, or a, it's going to be square root of 39. And that would be it. Okay? All right, so there's a whole other portion here that we didn't get to, and that's to talk about the conic sections and polar coordinates. I don't know exactly if we're just going to skip that or if we're going to do a quick overview next time, but I do want to get started with the next chapter, so I'll think about it and then we'll see. You have homework due on Sunday, and oh, I graded the first quiz, the quiz number 0, and I think I want to give people an opportunity to redeem themselves and prove to me that you can actually take the derivative and integral and simplify things like logs and trig functions. So I'll talk about how that setup will work. And also for honors, if you want an honors code, if you want to do the section switch, I'll give you an honors code so you can add and drop. If not, then you're all good. All right, see you guys on Monday.